Following video is a virtual field trip by Matt, Dan, Charlie, Nathan, and Dan. We will be characterising the difference between summit and flank eruptions at Mount Etna. This project will be based at Mount Etna in Sicily. This virtual field trip aims at investigating various lava flows across this site and characterising the difference between summit and flank eruptions. This will be done by investigating three characteristics. These characteristics are duration of eruption, elevation of eruption, and area of lava flow. To achieve the aim of the project, several objectives must be worked towards. These include assessing what characteristics lava flows caused by summit and flank eruptions at Mount Etna have, as well as analysing the similarities and differences of the specified characteristics for these two different eruption types. Additionally, the project will compare these characteristics to the theorised differences that researchers would expect to find. Firstly, this presentation will introduce the project site of Mount Etna. Following this, flank and summit eruptions will be explained with a focus on their frequency at Etna. Then the project will give further explanation to the three characteristics that are being compared for each type of eruption type. After this, the project will use Google Earth Pro to allow the lava flows being investigated to be shown and their characteristics analysed. The results will then be shown and analysed before a conclusion is made on whether there are differences between the eruption types, what these differences are, and an explanation for why this could be the case. Mount Etna is an active stratovolcano on the eastern coast of the island of Sicily. It is the largest volcano in Europe. Bennett 2004 suggested there are frequent periods of activity on its summit and its flanks every 1 to 20 years. Since 15,000 BC, there have been over 200 documented eruptions at Etna. Eruptions at this volcano tend to be of an effusive nature. The lava flows created by these effusive eruptions often have damaged or destroyed local population and farming areas, meaning that the risk posed by this lava flow hazard is considered fairly high. The almost constant activity at Mount Etna means there are several lava flows of varying size and type across the volcano. Thus, this area is ideal for a study of lava flows. These lava flows are generally caused by eruptions at Etna's summit or on its flanks. Therefore, the following section will explain how these eruptions occur and the frequency of them.
A flank eruption is a type of eruptive style that occurs on the flank instead of the summit. Etna had its first flank eruption in over a decade in late 2018. The location of a flank eruption is often controlled by local inflation stresses. Most flank eruptions within a central stratovolcano such as Etna are triggered by lateral draining of magma from its central conduit. This typically happens when the conduit becomes blocked, which forces the magma to move laterally and therefore reaching the surface on the flanks of the volcano. Though possible, it is rare to see a flank eruption that is entirely independent of the central conduit. Due to Etna's magmatic system, there are two styles of flank eruptions, known as lateral and eccentric. Lateral flank eruptions typically occur on the south and southeast side of Etna, relatively close to the main conduit. Eccentric flank eruptions, however, are rarer and are thought to be the result of dikes rising vertically from depth to the surface, which are not directly related to the central conduit system. Flank eruptions on Etna are interesting as they can be scattered, and new ones can appear during eruptive events such as in 1971, which formed the southeast crater, and in 2007, which formed the new southeast crater. The creation of these new craters has had a direct impact on the eruptive capacity of the volcano. These specific flank eruptions in the last 50 years has seen more than 200 eruptive episodes, seeing an on average greater number of lava fountains as well as ejected pyroclastic materials. This indicates that the newer craters are erupting more frequently than expected. Due to this, the lava flows are much shorter lasting, but despite this, they still pose a threat to tourist facilities on the flanks of Etna. While flank eruptions occur at Etna every few years, activity at the summit is nearly continuous. However, The historic record of Etna's activity is dominated by flank activity, which may have been due to a greater exposure to danger and damage of the local population from flank eruptions. Despite this, summit activity began to be recorded in a more systematic manner in the late 1930s and early 1940s, where flank eruptions were occurring a lot less frequently. But it was only in the late 1960s that summit activity began to be monitored more continuously. By 1973, a more complete and continuous monitoring of Etna's summit was conducted. Summit activity, much like flank eruptions, has different types of eruptive styles, which are persistent, paroxysmal, and subterminal. Persistent eruptions are the most common form of summit eruption on Etna. This type of eruption displays episodes of mild strombolian bursts with large outflowings of lava, typically from the main vent or subsidiary vents. However, the level of output during these types of eruptions are low, with lava flows struggling to reach past a few hundred meters. Paroxysmal eruptions are the most violent eruptions that occur on Etna and are characterized by an unusually high degree of explosivity, and at times are not even accompanied by lava effusion. A characteristic feature is the formation of tall eruption columns which can exceed 10 kilometers in height, as well as widespread ash falls. The final form of summit eruption on Etna are subterminal eruptions, and these eruptions have no defined individual characteristics, but are thought to be a combination of summit and lateral flank eruptions. Despite this, they are still considered to be summit eruptions due to the effusion rates of these eruptions being a lot lower than those of flank eruptions.
The aim of this study is to investigate the different characteristics between flank and summit eruptions. This will be done for a number of objectives, the first of which will be to map lava flows and compare the morphologies between the different eruption types. This will be done using Google Earth to draw polygons around the flows, helping to deduce area. Comparisons will then be made between the area of the flank and summit eruptions for any notable variations. The second objective is to compare vent elevation between eruption types. This will also be done using Google Earth to compare elevation of vents between summit and flank, with the assumption that summit vents should be higher. The third and final objective is to explore data for eruption duration and see if this explains the conclusion of the previous objectives. Five lava flows will be looked at in this study, the first of which is from October 30th, 1986, where a system of new eruptive fissures propagating from the southeast crater began to eject lava fountains. Activity continued vigorously through to the end of 1986, gradually decreased until it completely ceased on the 27th of February 1987. The second lava flow is the 1999 Eastern Flow. This erupted from three primary vents located along a fissure system between the 4th of February and the 14th of November. Its long-lived effusive activity from fissures at the southeast and east-southeast base of the southeast crater cone. The third lava flow is from the same year, but on the western side of the volcano. It occurred from the 17th of October to the 5th of November, considerably shorter than the previous one from the same year, and took place as a discontinuous lava overflow from the western rim of the Boca Nuova crater. The fourth lava flow is from 2001, from an eruption from July 17th to August 9th, and 7 eruptive fissures, all of which produced their own lava flows. This dramatically modified the morphology of the southern flank, producing large pyroclastic cones. And the final lava flow is from the November 13th, 2002. An intense activity at the summit craters and multiple lava flow fields were created cause overwhelming morphological changes, creating pyroclastic cones over 200 meters higher than the pre-eruption surface, considerably larger than the pyroclastic cones formed through the 2001 eruption.
In terms of our first objective here, you can see we've mapped the lava flows in Google Earth. When looking at the originating locations of the lava flows, it can be seen that the summit eruptions exclusively erupt from the summit craters, the southeast crater here being next to 1999 east eruption originating point, and the northeast crater up here by the 1999 west originating point. Whilst flank eruptions occur throughout Etna. The 1986 eruption even starts only 700 meters away from the summit craters, but due to it being on the slope and being made of a complex system of fissures, is still a flank eruption. The two 1999 eruptions, however, rather than being fissures, were collapsing lava domes from the main conduit of the northeast and southeast craters. The way lava travels, however, is not separated by eruption type. This is dictated largely by topography, as differing slope angles will move lava in different directions down different slopes. This can be seen especially in the 2001 eruption that produced a long, thin flow due to it being constrained in a valley, whereas the 2002 eruption, still a flank eruption, caused a large fan-like shape where it travelled evenly down slope before separating into different channels, as we can see underneath the polygon here. The area of these polygons can be calculated using Google Earth and can be seen in Table 1 here. The area of lava flows produced by summit eruptions are less on average than that of flank eruptions by 0.535 kilometers squared, albeit a part of a smaller sample size. Reasons for this are covered in a later slide. Possible reasons for this area difference are a difference in eruption activity. Aconella and Neri looked at flank eruptions in 2002 and suggested that flank eruptions tend to be more effusive and slow, releasing more lava over a longer period, leading to larger flows, whereas summit eruptions tend to be shorter and a lot more violent. And it's here it would have been useful to have the ejecta dataset so we could measure differences in the amount of airborne tephra and ejecta between flank eruptions and summit eruptions, but again we'll get onto the limitations in a later slide. Jumping to objective 3 and talking about the duration of the eruption, it provides further evidence for why the area of the lava flows differ. In table, and we can see this in table 2. Here we go. By using the start and end dates from a study by Maxime Lejoff, looking at the flows and eruptions in the past 2,750 years of Etna, and selecting eruptions after the 1971, the year in which Etna's eruption pattern changed to what we're currently experiencing, we can see that on average, flank eruptions lasted 30 days longer than summit eruptions, allowing for the eruption to produce more lava and create the larger lava flows seen in Table 1 and on Google Earth. The last factor to look at is elevation, or in objective 2. Looking now at Table 3, we constructed it using data from Manga and Ventura's 2005 book Kinematics and Dynamics of Lava Flows, and we also brought in some data from a study by Tarquini conducted in 2011, and we also used some of our Google Earth elevations from our polygons. Table 3 shows that on average the difference in elevation between the summit and the flank eruptions on average is about 675 meters. This is probably due to summit eruptions occurring at the summit craters, the highest point of Etna, as this is the release point of the main conduit, whilst flank eruptions are sill-like horizontal intrusions from the main conduit, emerging on slopes in the form of cones and fissures, so will always be below the summit. Interestingly, the range in elevation differs. Underneath Table 3, we can see there are different ranges. Summit eruptions occur over a 334 meter range, whilst flank eruptions occur over a 1,400 meter range in elevation. This is probably because the different summit craters only occupy a range of about 2,900 meters above sea level to 3,300 meters above sea level. When looking at the elevation profile on Google Earth, whilst a horizontal intrusion can occur in any directions from the main conduit at a much larger range of 1,400 meters. implications of this are the modelling of where flank eruptions will occur is much more difficult, and therefore producing hazard maps from it to declare risk from the various hazards of flank eruptions is more difficult because spatially they could be in a lot more places than just flank eruptions confined to the craters in only a 300-meter range. Overall, really to conclude this data is that summit eruptions occur higher for less time than the more effusive, longer-lived flank eruptions. Furthermore, spatially, in sort of X, Y, and Z, flank eruptions are more likely to occur over a wide range of areas, while summit eruptions are confined to the summit craters. Now moving on to limitations of our study. Our first limitation was our use of area as an eruption characteristic. Now, whilst area might be indicative of the size of an eruption, not knowing the underlying ground means that there could have been infilling of cracks, fissures, valleys that we just don't know about, meaning more lava might have come out of the volcano than we're suggesting, meaning the eruption could have been completely different than what we're suggesting, leading us to incorrect conclusions. Our second limitation was our lack of using effusion rate, tephra volume, and lava volume, and indeed also lava temperature in quantifying better the intensity of these eruptions. Now we know summit eruptions are paroxysmal, which means that they give off less lava but produce more tephra and fire fountaining and produce more material in that sense than a flank eruption would. So it would be a better characteristic to look at the intensity of the eruption. We could also better understand the way the lava moves down the volcano if we had lava temperature, because lava temperature ultimately decides how plastic a lava is alongside silica content. This could help us decipher the speed and possibly make sense of why some lava flows that lasted longer had shorter lava flows than other flank eruptions that perhaps only lasted a few days but produced lava fields that were much, much larger. And lastly, our last limitation was our sample size. We had quite a small sample size in the area when we were looking at the area of our lava flows, and that's simply because the maps that we use to show us where we need to look at on the volcano aren't very accurate. And the 5 lava flows that we looked at on Google Earth, we derived from Tarquini's 2011 paper that used high resolution DEMs to show where these lava flows were. We could have a larger sample size for the more data-driven duration and elevation characteristics because that data is a lot more easily available, especially for the time period we was looking at between sort of 1971 and 2005.
This is the last part of the presentation where the whole project is going to be summarized. This project have been focusing on one main point, and that was identifying the differences between summit and flank eruptions. The main characteristics were duration, elevation, and area of flow. This has been achieved by investigation of the characteristics, as was said earlier. After that, it was crucial to assess these characteristics, analyze any similarities and differences, and compare these results against theorized differences. In order to achieve this, Google Earth and few publications were used, which are in the reference list provided with this presentation. This presentation also briefly introduced the Mount Etna site and the types of eruptions. In the Google Earth, there were mapped flank and summit eruptions since 1986. After that, an analysis was done, and based on this analysis, it was found out that flank eruptions are more effusive and slow than summit eruptions, therefore they release more lava. On the other hand, summit eruptions are more violent and shorter than flank eruptions. In other words, this project has found out a couple differences in duration, elevation, and area of flow between the two types of eruptions that are occurring on Mount Etna.